Alright, this is my second video on solving trig equations. If you missed the first one, go check it out. But in this one, we're going to discuss solving trig equations that are essentially going to be quadratic. So we're going to use factoring, or there's going to be multiple trig expressions in there, so we might need to use some factoring as well. And then we're also going to use identities. And so if you don't know about identities, let me just hit you with a couple and see if it sparks your memory. If it doesn't, then you might want to go to my videos on identities. But there are identities like sine squared of x plus cosine squared of x equals 1, or cotangent of x equals 1 over tangent. These are identities where we could say, hey, one thing equals another, right? And so we're going to use those in solving equations to help us solve equations as well. So let's get started. If this is the video for you, then good. Here we go. So the first kind is we're going to solve by factoring out a greatest common factor. So the instructions say solve the equation for the interval 0 to 2 pi, which means we're just going to find our answers. So the first thing we're going to do is we're going to set the equation equal to 0. One thing you don't want to do is you would not want to do, and I'll show it right here, you would not want to divide both sides by cosine, because what that's going to do is it's actually going to cause you to lose answers. I have students who do it all the time, but in this case, when you do that, you end up losing some of the answers that you would have had, and so it causes you obviously to get the problem wrong. So better would be to subtract cosine from both sides, and we can't combine these terms, so we'll just leave it as 2 cosine squared of x minus cosine of x equals 0. And now that we have two terms that share a cosine, we can factor out the GCF. So we're going to factor, and so I'm going to take out cosine of x, and it's going to leave me with 2 cosine of x minus 1 equals 0. And the reason we wanted it set equal to 0 was because if I can figure out when this factor equals 0, when cosine of x equals 0, then I don't care about what the other factor equals, the 2 cosine of x minus 1, because 0 times anything is 0. And if I could figure out when this factor, 2 cosine of x minus 1 equals 0, if I can find when that equals 1, then I don't care about what the cosine of x equals on the outside, because 0 times anything is 1. So we're going to set up two equations with each factor, right? Create an equation for each factor and solve. Okay, and solve. And that should work out nicely in all the problems we do today. So that's going to be the basic steps for all these problems. We're going to set the equation equal to 0, we're going to factor in whatever way is necessary, and then we're going to create an equation for each factor and solve. So cosine of x is 0 at x equals pi over 2 and 3 pi over 2. And then we have to solve this one. That would be cosine of x by itself equals, add the 1, divide by 2, so 1/2. And cosine is going to be 1/2 in the first quadrant, so pi over 3. And in the fourth quadrant, so 5 pi over 3. Alright, so we have 4 answers. There they are. And that is all our answers in the interval of 0 to 2 pi. Okay. This one says solve for all solutions, so let's do what we just talked about. We're going to set it equal to 0. So it would be 2 secant of x sine of x minus rad 3 secant of x equals 0. Greatest common factor is going to be that secant of x. So we'll pull that out, and we'll be left with 2 sine of x minus rad 3 equals 0. So then we're going to set up our two equations. Secant of x equals 0, and 2 sine of x minus rad 3 equals 0. Okay, so this one requires a little bit of thinking. Here we go. Secant of x equals 0. Remember, secant is the reciprocal of cosine. So if the secant of x equals 0, and you take this, and let's say we want to think about it in terms of cosine, right? If the secant is 0, we can make this a fraction and flip it. So then we would say that the cosine of x is equivalent to 1 over 0. And what's 1 over 0? You got it. I know you said it. You said it with me. It's undefined. And is it ever possible for cosine to be undefined? Yes or no? Yes or no? I'll give you 3 seconds. 3, 2, 1. Yep. The answer is no. So then x has no solution here. So this essentially doesn't give us any answers. And then in this one, we'd add rad 3, divide by 2. So sine of x equals rad 3 over 2. And so then we're saying to ourselves, where's sine rad 3 over 2? And that's going to be in the first quadrant and the second quadrant. And so pi over 3 is when sine is rad 3 over 2, or 60 degrees. And then 2 pi over 3, or 120 degrees. So those would be our 2 answers. So we really only have 2 answers for this one because the secant can't equal 0. And so then we just have those 2. And that happens sometimes. It also happens, don't forget, for other cases where no solution would take place. Here's a reminder, no solution would happen, right, if like secant equals 0, so that's a thing, right, because that's not possible, so no solution there. Same thing for cosecant, that would never equal 0. Also things that can't happen is like if sine of x equals 2. Remember, sine of x is never going to be, if you think of the graph, goes like this, right? That's a sine graph. The highest or lowest that a sine graph ever goes is 1 or negative 1. And so it would never equal 2. Same thing for cosine of x, couldn't equal like negative 2. The ratios that they equal have to be in between 1 and negative 1. So this is, all 4 of those scenarios would be where you wouldn't be able to find an angle for x. Okay, let's keep going. So now we're going to just talk about factoring. So factoring is a thing, got to be able to do it. Alright, so hopefully this does not scare you. If this does scare you, then off to the side, okay, it's already set equal to 0. Off to the side, what you can do is instead of saying secant of theta minus 4 equals 0, you could say x to the 4th minus 4 equals 0. And you should be able to factor this. If you can't, I've got a video on my page that teaches you to factor those things. But you should be able to factor this. If not, check out the video. But this is difference of squares. And so it would be like x squared minus 2 and x squared plus 2 equals 0. Okay? And so then I'm just going to translate that back over here. And I'll call it secant squared of theta minus 2 and secant squared of theta plus 2. And then I'm going to set each factor equal to 0 because now we can use the square roots and move forward. So secant squared of theta minus 2 equals 0. Let's solve. We'd add 2, so secant squared of theta equals 2. Square root both sides, and don't forget the plus or minus. Secant of theta equals plus or minus rad 2. And so once again, if secant is rad 2, then the reciprocal, if it helps you, cosine of theta is going to be plus or minus rad 2 over 2. If that makes it helpful to think that way, then do that. Theta then is going to be, right, 0, or from 0 to 2 pi would be pi over 4, right, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Those would be your 4 answers in the interval from 0 to 2 pi for that factor. Then we've got to do this one. Secant squared of theta plus 2 equals 0. Subtract 2, we get secant squared of theta equals negative 2. Square root. And what happens when you square root a negative? Right? When you square root a negative, you're going to end up getting, right, an imaginary number. So this is going to give us no solution as well. So our only answers are going to be these guys right here. Okay? Next one is a trinomial, and sometimes people struggle with factoring trinomials, but let's hope not. We'd subtract 1 because we want to set it equal to 0, so we'll have 2 sine squared of x plus sine of x minus 1 equals 0. And once again, if you don't like looking at it with the signs, you could say 2x squared plus x minus 1 equals 0, and this is a pretty straightforward problem that we should have been able to do in Algebra 2 and so forth. So we've just got to factor it, right, equals 0. What multiplies to 2x squared? 2x and x. And then what multiplies to negative 1 would be 1 and negative 1, and you just have to put it in the right spot so that it multiplies out to the original problem. So I think it would look like this, and now we can translate that back, okay? So then that would be 2 sine of x minus 1 and sine of x plus 1. So if it helps you, utilize that. It's kind of nice, but here we go. Then I'm going to set each one equal to 0, so that would be the sine of x needs to equal 1/2, and in this case the sine of x needs to equal negative 1. And from there I'm just going to solve. This one would be x equals pi over 6 and 5 pi over 6. And sine is negative 1 only at 3 pi over 2. Okay? So you can use factoring in whatever way, but remember it's got to be set equal to 0 first. Okay? Last one, let's get to this idea of, let's get to the idea of using identities in order to help you solve. So here's the goal, right? So when you're looking at cosine squared minus sine squared, you could factor this, but the problem is this is like trying to solve the equation x squared minus y squared equals 0. This is tough to solve and very difficult because you have two variables but one equation. Usually if you only have one equation, you have to only have one variable. So what a identity does is it helps you get everything in terms of one trig function. So your goal is to sub in something, right, using an identity, substitute in something that will get only, oh my word, only one trig function in the problem. So in this case, you got two roads you can go in the problem. You could go with the fact that cosine squared of theta is 1 minus sine squared, or if you remember, sine squared is 1 minus cosine squared. So either way, you don't want to do both because then you're just back to where you started, but you do want to do one of them. So I'll pick this one, right? So for cosine squared, I'm going to substitute in 1 minus sine squared. And now notice in my equation, I have only sines left in the problem, and this makes it much easier to solve. So we'll combine like terms. 1 minus 2 sine squared of x equals 0. I'll have 1 equals 2 sine squared of x. I'll divide by 2. Get 1/2 equals sine squared. And then we'll square root. And the square root of 1/2, square root 1, that's 1. Square root 2, that's rad 2. So this will end up being rad 2 over 2. And don't forget the plus or minus. And when does sine equal positive rad 2 over 2? That's in the first two quadrants at pi over 4 and 3 pi over 4. And then the second two quadrants, third and fourth quadrant at 5 pi over 4 is negative rad 2 over 2, and 7 pi over 4 is negative rad 2 over 2. Okay? That's it. Those are kind of the ways in which we have to solve. I do want to go back to one problem real quick. And I think I said solve for all solutions. It's been bugging me as I've been making this video. It says solve for all solutions, so I wasn't quite done with this one. Remember, finding all solutions means that I should have said x equals pi over 3 plus, and a coterminal angle is found by doing 2 pi n, and x equals 2 pi over 3 plus 2 pi n, and that's going to be our coterminal angle. So this is actually the correct answer, and there's no way to write this fancier. That's about as fancy as it gets, and so that would be the right answer for this problem. So hopefully that's good, and thanks for joining me. Have a great day. Talk to you soon.